All right, welcome back. We are going to talk about another theorem today that will help us prove that right triangles are congruent. And that theorem is called the Hypotenuse Leg Theorem. Here we have a diagram that shows us two sides in a triangle are congruent and a not included angle. And it's very clear when you look at these two examples that these are not congruent triangles. So that is the side-side angle triangle congruence that we've talked about. We know that side angle is not a triangle congruence theorem. We've talked about that. It spells a bad word backwards, so that's one way to remember that that is not a triangle congruence theorem. Okay. However, something interesting happens if we say that the triangles are right triangles. So let's take a look. When we have a right triangle, we have some specific terms we can use. The right angle is always opposite what's called the hypotenuse. The hypotenuse is the longest side of the triangle. Okay, so you can always think of that right angle as pointing to the triangle. So if I were just to put like a little line right there, it kind of looks like an arrow with the right angle symbol. It points to the hypotenuse. And the other two sides are called legs. All right, so that's kind of our basic definition stuff that we need for right triangles. So our hypotenuse leg theorem says if you have two right triangles, okay, as long as there's a right angle in both of them, and we know that their hypotenuses are congruent and one of their legs are congruent, then the triangles are congruent, which means all their angles and all their sides are congruent. Well, let's take a look. There are three conditions that we need in order for the hypotenuse leg theorem to be true. Those conditions are that you have two right triangles and that they have congruent hypotenuses and one of their legs are congruent. Okay, so let's just go ahead and use that and see if we can use that information to prove that two triangles are congruent. So there's a basketball backboard here and its brackets, the way that it's secured to the pole by brackets are shown in the picture. And they're telling us that angle ADC and BDC are right angles, so we've got that marked that there's right angles there. AC and BC are congruent, so those are the hypotenuse, right? Each of the hypotenuses is congruent. And they're asking us, are those two triangles congruent? Well, let's see if these three conditions are met. We're given that we have right angles, so they're right triangles, so we have that first condition is met. The second condition, we do know that the hypotenuses are congruent. AC is congruent to BC, that was given up here. Is there a pair of congruent legs? Well, we're not given that information, but we could say that CD is congruent to itself. They share that side, and that would be the reflexive property. So yes, actually those two triangles are congruent. That would be using the hypotenuse leg theorem. Okay, we would have a hypotenuse and a leg congruent to the hypotenuse and leg in another triangle. Here's one for you to try. Go ahead and pause the video and see if you can do this proof on your own. All right, let's take a look. It tells us that angle PRS and RPQ are right angles. Those are marked in the diagram. And that SP and QR are congruent, so they're telling us the hypotenuses are congruent. Are the triangles congruent? Very, very similar to the last one, okay? So we know that the hypotenuse, we have two right triangles. So the first condition, we have two right triangles, okay? That's met. We also know that the hypotenuses are congruent. So the third thing, we need to have the legs congruent. Well, PR, segment PR, is congruent to, and in the other one it would be RP, okay? And what would the reasoning be for that? What would our justification be? That's the reflexive property. Okay, so now we have the hypotenuse and leg, right? And we have a right triangle. Therefore, and these three dots, I think I've mentioned this before if we use these three dots in a triangle. Therefore, triangle PRS is congruent to triangle RPQ. And what's our justification for that? Hypotenuse leg theorem. And you can go ahead and abbreviate that as well. All right, here's one using the hypotenuse leg theorem. We just need to provide justifications in this one. They're telling us that segment BE bisects AD. So think about what that means as a bisector. And it bisects it at point C. Okay, AB is perpendicular to BC. So they're telling us this side and this side are perpendicular, which gives us the 90-degree angle. DE is perpendicular to EC, so DE perpendicular to EC, another 90-degree angle. And AB is congruent to DE. Okay, so we have those sides marked. Prove that the triangles are congruent. Well, BE bisects AD. This segment right here is a bisector of AD. Okay, that's given, right? Well, and then it says AC is congruent to DC. Why would AC be congruent to DC? I'm going to go ahead and write this one in blue. Why would this segment be congruent to that segment? Well, what would our justification be? Well, if BE is a bisector of AD, that means it cuts it into two equal halves. So that's the definition of a segment bisector. AB perpendicular to BC and DE perpendicular to EC, that was given. Okay. Triangle ABC and DEC are right triangles. That's just the definition of perpendicular, right? If the lines are perpendicular, then it creates 90-degree angles, or right angles. ABC and DEC are right triangles. Well, that's the definition of a right triangle. It's a right triangle if it has a 90-degree angle. AB congruent to DE. What is our reasoning for that? Well, that's up here in our given section, so that's a given. So they're concluding now that the triangles are congruent because we have the hypotenuse leg and a right angle. So that's the hypotenuse leg theorem. Here's one for you to try. Go ahead and pause the video and we'll come back and do this one together. All right, I hope you gave that one a try. Let's take a look. They're telling us that CD is congruent to EA, and that's marked on the diagram. AD is the perpendicular bisector of CE. Let's go ahead and mark that right away. What does that mean? It says that AD is the perpendicular bisector. Well, perpendicular means that we have 90-degree angles here, right? Two 90-degree angles. And it also bisects CE. That tells us that this segment right here is congruent to that segment right there. Can we conclude, or how do we prove that the two triangles are congruent? Well, I think we have everything we need. We can say triangle CBD is congruent to triangle EBA. Whoops, messed that one up, hang on. Triangle EBA by the hypotenuse leg theorem. And the reason for that is CB, side CB, is congruent to side EB, right? And that's true by the definition of segment bisector, right? It's the exact same process in the last slide. So you could write out each of those items in proof form. This would be the only piece of information that was missing, so that you have the hypotenuse is congruent, that was given. 90-degree angles were given. We can prove that those two are congruent because they gave us that AD was a perpendicular bisector. So therefore, they're congruent by the hypotenuse leg theorem. Here is a lesson check for you. Go ahead and complete this one and bring it to class next time. And we'll see you then.